Part 2 of lecture 2 viscosity, fluidity, or we call ความหนืด. Before we go to these topics, we back to the previous property. Total energy E is equal to initial energy plus the kinetic energy and plus potential energy. E we divided by mass, so we got this equation. Okay. For the viscosity is ability of the freely flow of fluid. Okay, and we use the two parameters to represent the viscosity of the fluid. The first we call the mu. Use mu. The name is dynamic viscosity. The unit is Newton sec per square meter. And the other parameter is the nu. We use this nu. Kinematics viscosity unit is square meter per second. Okay, so we can write this is equation for mu is equal to, it's very similar spelling, mu divided by density. Okay, we can prove the unit of the news by if we convert from Newton. Okay, Newton is kilogram times meter per sec square and times second divided by square meter. So kilogram is cancelled, so we can prove that the unit of new is equal to square meter divided by second. So this is the same as this, the cubic meter squared divided by second. Okay, the next property to explain the relationship between the shear stress and velocity gradients. Okay, before we go to detail of this, I would like to explain what is the shear stress. You can look at on the right hand side here. If we, for example, this is a box, is cube of the fluid. If we apply the force, apply this force on the cube of fluid, okay, we expect that this fluid will be deformed like this, because stress in this case, the area of the fluid is A, so the stress is mean the stress is equal to force divided by area. Okay, this is stress of the definition of the stress. And for when the fluid is deformed, it's deformed like this. Okay, this is deformed, and we can measure the distance change from this is delta x. Okay, it's the displacement of the fluid particle. So in this case, if we divided delta x by L is mean the height of the fluid particle, so it means we got the strain. And in this case, the stress FOA is linear proportion to delta x by L. Okay, that is the source or the and this can apply for the left hand side. If we put the fluid between the two plates, the bottom one is a fixed plate and on the top one is a moving plate. Okay, apply the force P on the top plate, and we expect that the velocity of the fluid increase. Okay, this is a velocity profile of the fluid increase with the y. So if in this case, do the change of velocity du with respect to the height dy is we expect there is a direct proportion between shear stress P is a function linear proportion to the du over dy. So that is this equation where this equation come from. So it means shear stress is the direct proportion to the velocity gradients, and the constant is the mu. Okay. So if we from experiment we found that if we plot the curve between the velocity gradient du over dy with respect to the shear stress, this fluid we got the constant slope mu for air, water, and crude oil. Okay, that is we call the linear relationships. Okay, but some case in the middle is mu is constant, but in some case the mu is not constant. For example, the top one, if it's not constant, so we call the non-Newtonian fluid. Okay, they have two types of the one is we call the shear thinning fluid. It means the mu slope decrease with the shear increase. Okay, look like this. mu2 less than mu1. In this case, it means that, for example, the latex pen. Okay, if you apply the force on the brush, okay, it moves smoothly on the wall. Once we do painting on the wall or something. Okay, so in this case, it's like this. It's the shear thinning fluid. Okay, and the second case we call the shear thickening. It means the mu increase with the shear increase. Okay, so in this case, once the shear stress increase, the mu increase. Example of this is water corn starch. Okay, or water sand mixture. Okay, I will show you some clip about this corn non-Newtonian fluid and viscous flow. This show what is the viscosity look like. On the left hand side is like water, and right hand side is like the wax. Wax is have the high viscosity. If we can pour the this is for the high viscosity of the fluid, or can be the honey or the wax. It look like this. Different viscosity of fluid. And next, this is corn starch. Okay. Okay. This constant, if we apply the high stress, the viscosity increase. Okay, with the high stress. Okay.